Hello again. All right, so now it's time for us to talk more about testing. In particular, we're going to start off talking about test cases and general properties of tests that we want to see. We've already talked about this previously in MSci 245, but the key components to any test is for us to have a notion of arrange, act, and assert. And so when we arrange, this is when we set up whatever the input is to the code or the input to the test that we're going to be running. So we've got to set up things in advance. We want to know what the incoming state is to the system, because everything depends upon what the input is. So we have to spend some time to set that all up. Then it's time to act. And this is basically to run the test or to execute the code with whatever the input is that we want to have. All right. And then the last thing that we need to do is we need to assert. And this is our check in our test, where we check whatever the output, whatever the results were, against our expected output. So we went into the test with a notion, well, okay, given this is the input, let's say we were testing addition and our input was 1 and 2. Well, we would expect our output of the addition of 1 and 2 to be 3. And so we would check to see what the actual result that came back from however we implemented addition to our expected result and see, oh, did it match our expectations? If it matches our expectations, we've passed our test. If it does not meet or match our expectations, we have failed our test. As simple as that. So it's basically set things up, run the test, check to see that it worked the way we expected. That's the basics of a test case. Now, we said we're going to start talking about end-to-end tests, or in Rails, we call these systems tests. So what does it mean to arrange for a systems test? Well, often it doesn't mean much of anything, okay? So most of the times for an end-to-end test, there's no setup. We're just going to go and test something. So there's, you could think about it again. Our end-to-end tests are all at the user interface level. So it really is, it's like we've started up our application from scratch. That's usually the initial conditions, the initial setup that we're going to have, which is it's a blank slate. We haven't done anything with it. Now, sometimes you do want to do some things in advance. So sometimes our arrange is going to be basically, we could be arrange, could be something like, add items to a database. So before, maybe we've got some website that's dealing with books. Maybe before we test something on that site, it would be nice if there were a few books in there. Now we could go and just run the test to be like, yeah, we need to go and add a book, add a book, add a book, and then check to see something that we wanted to. That's one way to do it, is to do the arranging as part of the overall flow. And it's not really arranging, it's largely, that's all acting. That's one large system test. Can I add a bunch of things and then check something? So this actually is, no, what we're going to do is before we do anything with the user interface, we're going to do some setup and we're going to do some insertions of, let's say, books into the database using our active model for like a books object. And we're going to stick those books in there, and great, they're in there. Then we're going to go to the user interface and lo and behold, the books are there, and we don't have to use the interface to add the books. And that can actually make writing the test a lot easier for us, because otherwise you have to go to the trouble to be like, yeah, I have to fill out the form to add the book, as opposed to just make a call to your books object to your book's model to add a book to the database. So this can be handy at times, absolutely. But a lot of times it's just one big whole bunch of things that we're going to do. We're going to go to a page, fill out the forms, go to the next page, check this, check that. Again, the end-to-end tests are all about creating this nice workflow and testing these flows through the system. So it seems that's actually pretty natural to do that. All right. So I don't have anything else to say there. What else? I gotta get to my next page. I gotta turn my notes. Remind myself. Oh, that did remind me. So I mentioned, adding things to the database. So we didn't make this very clear in 245, and I want to make it clear here that this thing that we call seeding the database, when we use the seeds.rb file, this is not for testing. Okay, so the idea is not to actually load in a bunch of test data with seeds.rb. If we need that data loaded, we're going to do that as part of our setup and our arrange step for a test. We're gonna make it explicit that, oh, this test needs this data in the database for the purpose of the test. What it means to seed the database, this is for loading data that the app needs to run. So this might be, oh yeah, we've got a default account for an administrator. When we start the system, we seed the accounts, the users, with the admin account, and a default password, so that the first person who comes to the system can log in as the administrator, change their, the email and the password, and they become the administrator. And everyone else who comes into the system, oh, they're just regular users. So that's something that you would do with your seeds. Or, the spell manager, I think it was sort of legitimate for us to load in all those spells if we were really to believe that they were default data that needed to be in there for the user, and it was a custom application for the user. It might make sense. Otherwise, we would be filling the spell manager with all sorts of spells that some other user doesn't care about, and that actually wouldn't make sense. It would have been better probably to actually have had some sort of feature and functionality in the spell manager to let us read in a file of spells and load that into the database. But otherwise, the database would have started blank, would have not had any spells or spell books in it. But it certainly was an easy way for you guys to get data into it and see what was going on. And so we sort of bent the official rules of what that was in 245. But you should keep in mind that your seeds, doing the seeds and database seed is not about loading test data. Okay, so don't think of it that way. Think of it again as this is what needs to be in the database into the system for the application actually to start working. Could be, some important configuration information and things like this. All right. So that's pretty reasonable. So I said, an example of arranging might have been loading some data. Great. Or often it's not. What about an example for acting for an end-to-end test? Well, that could be something as simple as, well, let's go visit the home page and click on a link to create a new account. So that's my action. And what would my assert be? I would want to see that I actually ended up on the create account page. Basically, can I go to the home page and then click a link from the home page to create an account page? Did the UI get built enough so that we can do those simple navigations? And that could be the limits of a test. All right. So that's you can of course come up with much more complex end-to-end tests, but that's just an example. All right. Now there's a whole bunch of things that we need to keep in mind usually when we make tests. And there's this nice acronym that people came up with, and it's actually came up in sort of the agile world, and in particular driven through this notion of test-driven development, which we haven't talked about yet, but we will. But there's this notion, this acronym called FIRST. So you can think of these as the first, these are properties of good tests. And so as we write our test, we're going to want to keep and think about these in mind. So the first one, F, stands for fast. Okay, so you want your tests to run fast. We've already said end-to-end tests don't run fast, and so you really shouldn't have too many. You do not need to worry about that at all right now. First of all, you're actually not going to run your end-to-end tests through a browser. That's what this whole rack test is that we set up. It's actually much faster than running through a browser. And the other thing is, when you have no tests, you don't really worry about them running that fast. Like at the moment, you have 0 tests in your system. So start adding tests. That's great. It's still going to run fast. This is more of a problem for these big projects who've gone really far, and it's a big complex thing. Well, you're going to end up eventually with gigantic numbers of tests when you get down to the level of the unit tests, and you want the unit tests to run really, really, really fast because you have so many of them. The end-to-end tests, no, they're not going to run fast, but you're not going to have as many. Again, you don't need to worry about that at all right now because your goal is to get some tests. And so any tests is better than no tests, whether or not they run fast or not. Much more important for things to be thinking about when we write tests is I, which you will see variously on the web. There's both people who talk about I being independent. When FIRST was actually created, it wasn't independent, it was isolated. So people have modified the acronym over time. The two things are actually not entirely the same thing, although they sound like it. Independent, so if you're independent, this basically, the big point here is that a test should not depend on another test. And it's usually the notion of saying the other test has run before it. So there shouldn't be a notion of, oh yeah, I wrote this test and it's going to put my system in the current state. That's going to like add some users. That's great. And then I'm going to run this next test, and since I know that a user will be in there, it'll depend upon it, and it'll work correctly. This next test will work correctly. So people will be like, oh, first I test this, then I do this, then I do this, then I do this, and I do this. And these tests are chained together. They're all dependent upon what happened as the last test. Absolutely not. Horrible thing to do. You need every single test that you write to be independent of the other tests. Now, the great thing is we're going to use a testing framework called Minitest, and it really makes this actually pretty easy for us to do. And so that's not a huge issue and a huge concern. Now, what was this isolated? So to isolate your test, this really, what the original people wanted I to be about was that the test needs to tell you what went wrong, when a test fails, what went wrong, and where did it go wrong. Okay, so you don't want to run a test or a whole bunch of tests and just get a message that says something's wrong. Oh, now you got to figure it out. They really wanted it to be like, this test helps you know where there's a problem in your system quite specifically, and what is it that went wrong. And so really one of the big things here, this sort of leads to the idea, is that when you write a test, you should try to test one thing. So that should be like one idea in that test that you're really doing per test, not 20. Now this isn't so some people take this rule and they go even one step further, and they're like, your test must only have one notion of asserting. So in other words, we talk about arrange, act, and assert. And so, I want to only see you assert one thing to be the case in that test. And that's why you'll keep to this notion that the test is really pure and small and focused. You know, sometimes it might make more sense to be like, you know, what I'm going to do is I'm going to be testing, you know, what are legal email addresses to be added to this form. I want to check a validation. Maybe you're going to check 10 valid email addresses. You're in a loop, you know, and there's going to be a whole bunch, there's going to be then 10 asserts. Well, if one of them fails, you'll find out, you'll figure it out. You'll probably when you do the assert, you'll write a nice message that says, this is the email address that failed. Okay, so don't be too stuck on the rules that you might see sometimes, but don't be like, oh, I'm going to write this huge test that really tests like 5 different things. It'll be great. It just calls it once. No, break it up into 5 different tests. Like don't cram different things in together into the same test. Now again, we're talking about end-to-end tests. The nature of them really is to be a workflow that you go from here to here to here. So this is a little tricky in that it's not necessarily going to be absolutely, the test is often going to have parts to it. Because you want to see, oh, does this happen, and then this happen, and this happen, and this happen. You're probably going to assert, you know, imagine you're going to test a whole bunch of things. You're going to want to see that, oh, as I went along, all of this worked. Oh, nope, it failed somewhere in this workflow. Okay, that's the way it is. You're testing the workflow. So it's not quite exactly the same concern, I think. I think a lot of this is for unit tests. When we get to there, the idea is those really need to be focused on really small stuff, but keep that in mind. But independent is a really important thing. The R in first is repeatable. All right, so this means that every time you run the test, that it behaves exactly the same way. So you shouldn't run the test one moment and get it and says it passed, and the next moment you run it and it fails, or you run it one day and it passes, and you make no changes to your code and it fails the next day. How could that be? Well, sometimes the tests depend upon the day of the week. You know, some sort of code is, oh, if it's Monday, behave like this. Well, when you tested it, hey, and it worked. Then it came the next day, and you tested it and it didn't work. So we'll look at things that you have to do to be careful about that. So especially any time that you're thinking about dates or times and stuff with a system, be aware, especially if it's anything that's based upon sort of the current date or the current time, that it's going to be extra tricky to test. The other thing is, I don't think we're going to be writing anything like this, but you could certainly imagine something that's stochastic, something that has randomness in it, and that would be a lot trickier to test. And so you wouldn't want to depend upon something random happening or not happening. So you do definitely want it to be repeatable. Otherwise, you're probably going to go insane, because it's going to one day work and the next not, and that's no fun. The S stands for self-validating. And this is where one of the things where the test frameworks basically, they're making this part, this is easy for us. So the idea of self-validating tests is the test reports pass or fail. And this is such a ingrained thing in the test frameworks today that's hard to even imagine that it was once a concern. But again, when people were coming up with these acronyms, the notions of the test framework sort of, oh, this is the way we do testing, and in a really consistent manner, didn't exist. People just wrote tests. So the frameworks help to guide us and do this. And so absolutely. So we're going to see you write tests inside of a test framework and you use the special assert statements. That is going to cause us to be reporting back, did it pass or fail? And what they meant by this is, for example, the big thing is you don't need, that is, you personally with your own eyes don't need to look at the results and compare it to the expected. You basically need to have a mechanism by which you're comparing automatically in the code that you write. So to the expected value. So you wouldn't want to be like, oh yeah, we're going to print some stuff out and then I have to go check, like, does it equal? No, it's got to be built into the test. So we got to make sure our tests are self-validating. Now the T, there's actually, again, there's two notions of T's that you'll see out there. There's timely and there's thorough. Timely means write the test when you write the code. Now for test-driven development, it means you write the test first and then you write the code to test the code. And we'll talk more about that. But basically, you should be writing the tests at the same time that you're writing the code. It shouldn't be that you write the code and then 3 weeks later you write the tests. Absolutely not. You should basically be doing them in sync with each other. While you're in the midst of developing the code, you should be developing the tests against the code. And I said tests. Often, yes, for even a single, like when we get to unit testing, a single method, you're likely to write multiple tests for a single method. We write more code to test our code than we write of our actual code in the program. All right, thorough. Thorough means that basically, you have worked hard to find all bugs. It can also mean a notion of coverage, which is sort of what actually happens when you're trying to find all bugs. Coverage is the idea that you're really working across a whole set of tests to make sure that the whole system has been tested, that there's no nooks and crannies that haven't been examined and tested. Coverage also talks about testing all the sort of code paths. So for example, if you have an if statement, if true, it does this code, else it does that code. If you only run tests that go through one of those branches, you won't have been actually be testing all of the code that you have in the system. So you want to think about that. So it's coverage both overall, but it's even within the code that you're testing, that you're both testing, both paths, both branches. And it can be difficult because you could have a huge number of potential branches, which actually means there's a huge number of potential paths through the code. It's not always possible to test all the paths, but you're going to work hard to really trying to find all the bugs and to have tested all of the lines of code in your system, which means you actually need a whole bunch of tests to try to be sure that you've tested all the possible ways the code could have run. All right, so let's skip ahead now to talk about test frameworks and how these test frameworks work and help support our notion of writing good tests. So test frameworks, and this really holds in general for, you've got all sorts of them out there, like JUnit for unit testing in Java. And what we're going to be doing is using Minitest. Minitest wonderfully is already nicely integrated with Rails, so we don't need to do anything special to turn it on. So it's there. Now, how is this going to help us write first tests? All right, so a lot of what I will say, well, there's actually not too much here with this, but the big thing that it does wonderfully is that it will automatically handle resetting the Rails app and the database after each test. Now, and that's really literally after every single individual tests, it cleans things up and they go back to the state they were in before the test started. All right. So that's going to help a lot with the notion of independence and actually repeatability, because repeatability, we always get back to the same state. So hopefully, it's because we're not going to have strange changes in our input, the behavior should stay the same. Independence, because even if you were to try to set up some data for another test, you'd probably fail. Okay, so because it's going to try to wipe everything out and away from you. The other thing, one of the other things it does is Minitest by default, it runs your tests in random order. So you have a whole bunch of them, it'll run them in random order. And so if you somehow did have dependencies created between your tests, and you could be doing this by, we're going to see that you write your tests inside of a class. And so you could have member variables, instance variables inside the class, and maybe you were maintaining state and you relied upon a test to set up a variable that then gets used in another test. A big, big no-no, don't do that. By running them in random test, Minitest is going to help trip you up. And so if you find your tests failing sometimes because they shouldn't be, there's like they worked before and now they don't, and there's no good reason, you can't think of anything like those whole date issues, it's probably because Minitest is running them nicely in random order for you. Do not disable this. This catches you doing things you shouldn't be doing. It's to protect you. And so that's, again, that really helps with the independence notion. And so the first one helps us with independence and repeatability. This one helps us with independence. And then finally, Minitest, and like all the frameworks, but it provides these nice special assert statements. And as well, it produces for us reports of basically pass fail. And so by using the assert and knowing whether things passed or failed the assert, the framework then is able to go, oh, this test that you were running failed this assert here, and it reports it to you. It's wonderful. And so this is all about, helping us with self-validating. And so the framework is really designed to go ahead and basically take care of self-validating for us, as long as we work within the framework. All right. So that's some of the key stuff that the test frameworks do that really are inspired by First. It's built into the frameworks, and that's great that we don't have to deal with that as much as we would. What about the other ones? What about Fast? Well, Fast is mainly a property of the type of test we do. So if we're running unit tests, they're going to, in general, be really fast. If we're running the integration tests, they're going to be slower. When we run end-to-end tests, they're going to be even slower. I will say, though, but Minitest itself has low overhead. And so it, compared to like RSpec, is a much faster framework. And so people, especially as their number of tests get to be huge, Minitest allows them to run them faster, which is a nice thing. But the big thing then, so Fast is not really in your control, other than be sure that you write largely a huge number of unit tests because they run fast. And don't do anything crazily slow inside your unit tests. And if anything's going to be crazily slow, that's probably an integration or a system level test. A system level meaning end to end, okay? Now, timely and thorough, though, the frameworks don't do much there for you, okay? So if you're going to be timely and thorough, this is about developer behavior. How do you behave? Do you write your tests at the same time as you're writing your code? And as well your skill. So to make sure that they're thorough, you need to be pretty skilled and be thinking about all the ways that your code behaves and how to test them. We'll give you some more helpful hints on how to be thorough in a later lecture, but it's on you. Now there are some tools. They're not part of the testing frameworks themselves, but there are some tools that will give you measurements of how much coverage you have, basically how many lines of code have your tests executed and gone through. At the moment, I'm not planning to have us use any of those, but they do exist and they're not that hard to turn on in Rails, which is nice. All right, so now we're at a point where let's really get down to talking about Minitest, because I really want us to get on to be able to write some end-to-end tests that are automated. You can write all the manual end-to-end tests that you want right now, but being able to do the automated one, we've got to get up to speed here. All right, so let's talk about the basics of Minitest. Well, I have a whole bunch of points here about Minitest to know. The key idea is that you start off and you write classes that inherit from Minitest. Now in Rails, we don't write classes that directly inherit from Minitest. We write classes that inherit from other classes that eventually inherit from Minitest. And so, but the idea is there's a chain back to Minitest. So we write a class, and it's basically a Minitest class. That's important. Otherwise, it's not just a generic class. It has to inherit all the behavior and functionality that the framework gives us for it to actually work. Now within that class, we write methods. Now, the cool thing is that each method of the class, and which class am I talking about? I'm talking about the classes that we're writing. So each method that starts with test underscore. So there's test underscore, and then you have a whole bunch of other stuff as its method name is run as an independent test. And so by independent test, I mean, again, Minitest is going to work with Rails, wipe everything out, run your test, reset everything for the next test, okay? What we do is we write long names for our tests. So we go test underscore, and then we might do something like invalid email addresses are rejected. You know, it's this long method name, because when Minitest reports to us whether a test passes or fails, it's going to use the name of the method to tell you this is the test that failed. So the name of the test is the method name. And every method in your class that starts with test underscore becomes a test that runs. It's really nice. All right. So also Minitest has a nice functionality that you can write. So if you write method named setup. So if you just, it's def setup. That method is run before every test in that class. So you might have some general thing that you need to get set up for every test or you want available. An example might be, yeah, I want to create a user in the system. All right, and so you call your users model and you create this user, and then you store that in a member variable, and then that member variable is available for the test that runs. And again, Minitest is going to wipe it all away before it runs the next test, but before it runs the next test, first it'll call setup, which would then create that user again, and that would be available for the next test. It's not the same one, it's a whole new, everything's wiped and reset. So, but it's rather than, if there's some common setup that you have for all of the tests in the class, it should go in this setup method rather than you copying and pasting that same code into every single method. So it's a handy tool to know about and to use. All right. I've already said this numerous times, but I'll just write it down. That Rails and Minitest restores state after each test. And that includes the database. Basically, my understanding is that all the database changes that you make while running a test are actually being run inside of a transaction. And then when your test ends, we just simply tell the database, don't commit that transaction, roll it back. And the whole thing unwinds, and we use the database basically to avoid actually ever actually changing the database. All right. Somehow I skipped 5 in my numbering. All right. 5. Everything in Minitest is plain old Ruby. Okay? So this means you write Ruby code. You don't have to learn any special new language to get up to speed to testing. You basically just need to know to be able to call some additional methods that exist, like assert. And then we'll talk in a moment about this special these special methods. You could call it a language, but they're really just special methods to be able to let us run the end-to-end tests and use the interface. We have to have something to be able to like click the links and stuff. And so, but it's not hard. So you just get to write a whole bunch of plain Ruby. So you already know Ruby. So there's no sort of huge ramp up here. A huge advantage over using something like RSpec and Cucumber, by the way. So you guys are already ready to go. Keep in mind, because it is plain Ruby, the class that you write can have non-test methods. So you don't have to have every method in there start with test underscore. But so you can have other methods so that you can write in a nice fashion. You don't just create gigantic methods. You can still program in a sensible manner. So you can create other methods to help your to write your tests. You know, as well, you have access. It's Rails wires everything up. So you have access to everything in your Rails. You know, for example, you have all access to your models, all the various helpers with the route paths and all that sort of stuff. It's all just there, just like you're writing Rails. And so it's just that it's there and you can access it. So you can call it directly. And you don't need to do anything special, includes or requires or anything like that. Rails has made it all available for you. Mentioned this before, but just to reiterate, there is a separate test database. All right, and this is to avoid contamination, I would actually say. From your dev database, because you're sitting there, you're coding all sorts of stuff, you're testing, you're trying, by testing, I mean, you launch the web app and you add users and you do things. Your development database is not necessarily in a clean state. So rather than try to wipe it out, which could really actually upset you, we're using a separate test database that always starts from a pure state and is getting restored then after every single test. So don't go mucking around with your test database. Okay, that would be a mistake. The migrations, though, and things like that, they happen as well. They both migrate into the development database and as well as the test database, so that the schemas all stay up to sync. If you've got a seeds file, when you do the seeds, you would be seeding both databases. So that's all the same. And yes, there are lots of ways, lots and lots of ways to assert. Okay, so now the most basic one, and let's continue this on the net. I'm going to erase, and I'm going to continue to talk about assert. So the most basic thing is just a method called assert. And so you go assert, and you put in some sort of test in here that returns a Boolean, so that's either true or false. And then if you wanted to, you could supply a message, but by default the message is null. So if you want an example, you could do, assert. If you wanted to, you can just do assert 1 is equal to 1. Hey, it's true. That's good. Yeah, I mean, the real thing is you instead of that, you've got something that's probably much more like, your expected is equal to, your expected is equal to whatever your results were. You're going to do some check or some test. I'm just picking equality here. But you could do all sorts of things that your results are less than the value 10. For whatever reason you needed to test that. You can do that. So the most basic one is an assert, and you're just checking some sort of statement. And does that statement return true? If so, the assertion has passed. If it returns false, the assertion has failed. If the assertion fails, the test has failed, and you get a report back from running the test that yes, that test has failed in that assertion there. Now, it can be nice to be alerted to more details, and so there are helper methods like assert equal, and you pass in the expected, and you pass in the actual, and you can have a message as well. And so the thing is, the reason to use something like this is you'll get a message that says expected did not equal actual. Oh, it's kind of a nice thing. When you get this, it just tells you this assert failed. It doesn't tell you the details of what the Boolean thing was in here, but this one will give you a more verbose sort of output. And this equal, by the way, is this sort of equality. There's another assert equal to do a different type of thing. It's all in the documentation. You can read about it. Another nice one, for example, is you can assert nil. And you've got some object, and you want to be sure that object is nil. And if that object was not nil, the assertion would fail, and it would say, I was expecting object to be nil, but it was not nil. Okay, so you get a message about it being about the nilness of it. There are lots and lots of these. You just go read about them in the documentation. Now there are some other handy things besides asserts that Minitest gives you that you can stick in there. These are common to other test frameworks. Is that you can write flunk and you can pass in some message, and this is explicitly you're like, well, often you're going to have this as an if statement. Well, if this blah 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 happened, well, I'm going to say the test has failed, and so we flunked the test. And by calling this, you're saying this test has failed, and you're going to have some message that goes along with that. Now, likewise, sometimes you might want to add a test and not bother to write it. You want to be explicit that you're not bothering to write it. Or you might temporarily have a test that you know needs to be fixed, isn't working right, and you don't want it to actually be like failing. And so then you can actually say, you can call skip in the test and pass a message if you want to. You can also call flunk and skip without messages. They're optional. But you can do skip, and that tells the test framework, stop running this test. We're just going to skip it. Report it as a skipped test, so it doesn't hold it against you. It's neither passed nor failed, it's skipped. So that's a handy thing to know. Again, there's tons of these things. All right. So I said you're going to write classes that inherit from Minitest. In Rails, the hierarchy looks like this. So at the very top, you have Minitest test class. And so normally, if you were just to be writing and using the Minitest framework outside of Rails, you would inherit from this test yourself. But in Rails, we have an active support test case. And again, this nice notion of test cases shows up here. And in fact, this is a simple, you can find this sitting in the directory test, and then there'll be a file test helper. .rb. And so this is actually a place where you could, if you had code or methods that you needed to be available across your entire testing suite, this is how you could get it in. And then all of your tests would inherit that code. Okay, so that's one way to get access to that. To do that, then Rails goes and makes this notion of, makes a class called the action dispatch. I actually don't know what active support and action dispatch mean. The class names after them, though, make a lot of sense, like test case. And this one is integration test. And this is what you use for all of your controller testing. Okay, so all your controller tests are integration tests. Then, inheriting from that is another action dispatch class called the system test case. And the big thing that this one does is this is where it adds Capybara. And Capybara is the gem that allows you to navigate through the user interface in code. And so this is where it shims it in to the system so that any test cases underneath this know about Capybara, but the controller test cases don't know anything about Capybara because, again, they're not at the user interface level. So that makes sense. But then we have that inherits from this is we have a class called the application system test case. And this is actually what you inherit from when you write system test cases. So you inherit from this, and this one happens to be found in test, and not surprisingly, it's in snake case, application, system, test case, RB, and you've actually already, I think, well, you might have already modified this, or maybe not, or maybe I had you modify. I think, yeah, I had you go in and modify this one already to turn off the parallelization of your test cases and turn off your fixtures. This one you haven't edited yet. I think it's a empty shell. And so in here, if you had code that you wanted to add to be available for your system tests, you could add it here, and then all of your system tests would inherit, because all the system tests inherit from this class. All right. So that's pretty nice. That's the hierarchy in Rails. Now, we've done that. You've seen some basics of Minitest. All we need to do now is learn a little bit of Capybara, and we can start writing end-to-end tests in Rails. So let's learn a little bit of Capybara. All right. So Capybara. And again, for both Capybara and Minitest and all this testing in Rails, there's all sorts of great documentation on the web. One thing to look for is often cheat sheets. One thing to be aware of, there's a whole group of people who do things with RSpec. And so some of the cheat sheets out there are written by people who use RSpec. And their calls to Capybara are similar but different than the calls in Capybara that you will often make with Minitest. So if you go looking up someone's cheat sheet, pay attention to, am I reading a Minitest cheat sheet here, or am I reading a RSpec cheat sheet? So, and cheat sheet, of course, is just a quick look up, a summary, but usually you look at them and you go, oh, I'm going to do that, and you can figure it out without reading the full documentation. It can often pay to look at the full documentation, though, of course. But nevertheless, so let's take a real simple thing. Simplest thing in Capybara is you have a method called visit. And again, you can use parentheses or not, as you know, in Ruby. And so it's visit, and you give it a URL. And then you're running this inside of a test, and it instructs basically your simulated user that you're running, that's like running the web browser, to go. It's like typing into your browser, oh, I want to go to http://www.uwaterloo.ca. So that's what it's like. Now, you're going to give it URLs for your application, not for the University of Waterloo. But you could, like, easily, as an example, you could say, yeah, I want to visit the root path of my application. And this, by the way, is a demonstration that, again, everything that you have in Rails is available to you here in the testing framework. And so, again, these are the helper paths that get set up in routes. And so rather than memorize what the root path is or the sign-up path or whatever, because, again, they could actually change on you. You could change your routes, but you'd still like to actually use the helper method so you don't have to hard code what all the paths are everywhere. This is great. So you can just say visit that, and that will simulate, it will literally go and interact with the Rails app and basically send, a GET request for that, and it will go fetch and it'll do the controller and get the HTML back, and you'll be able to then do the next thing that you want to do. All right, and of course you don't always have to use helper methods. You could hard code something in there, but I would actually usually recommend against hard coding unless it was really important for you to do that. So that also Capybara makes available to you its own set of really nice asserts. So there's a really nice one, for example, called assert current path. All right, and so you pass it a URL, and this is great. And so the point being is you might want to say, I've done all these actions with the user interface. I should be here now. Like maybe after you create an account, you know that you should end up on the user's page. Well, did I really end up on the user's page? Let's assert that my current path, the thing that's up in my, be like in my browser, is really where I expect to be. And I would have this be like my user's page or whatever the URL formed for that should be. I should have ended up there. So that's really handy. We want to interact with the system. Okay, so let's go and click some links on the page. So you could have, there's a method called click link. And you could specify, for example, the ID of the link. I'm copying examples from at the moment from the Capybara documentation. So when you look at the Capybara documentation, you go, hey, I've already seen this. And it's like, yeah, why am I going to create you new things? This again, these are the IDs, that you find in your HTML. Yeah, you might want to look again at looking at the cascading style sheets, because cascading style sheets talks a lot about this. But you'll have all sorts of elements on the page. But so you could have a link, which is an anchor tag, and it's got an href to take you somewhere. But you can also supply an ID here. Maybe this ID here is I don't know, you call it books or something, I don't know. So here you've made an anchor tag, and you want to actually, and so let's say, it's to navigate to the books, and so then it's the whole thing. So you've got this HTML, and to be sure that you're clicking on this link, you can have an ID in the tag, and so that you know specifically that it will then go through the page that you have currently in the simulated web browser, and it will go simulate clicking on that for you. And it will then cause that request to go to the Rails app and be processed. Yeah, this is great. I love it. Now, you don't always have to use IDs, although it is best to code with IDs of elements on the pages, because then you can have an ID and have it be fixed, and you can change like it from books. Maybe you do internationalization, or you decide to, you write it for another foreign language, and so instead of books, it's whatever other language you want to write in, but you kept this ID to be books. All right, so your test code could still work. And again, ID of link here would be changed with books for this example to be correct. Anyway, so you could click a link, and you can also say what is a link that has a certain text in it. So if I was to actually do the example here, I could say I'm going to click the link that has the word books in it. So it'll look at all the links on the page, and it'll find a link that has text books, and it'll click on it. If there's more than one link with books, you're probably going to run into a problem. And again, if someone decides to change the user interface, they're going to break the test. So is it that you really wanted to test that there's a link with the text books on it that I can click on it? Or did you want to test that I could click on, there is a link with an ID here of books that I wanted, so be careful about what you want to actually test. Sometimes you do want to test that there is a link that has the text books, and that's what I'm trying to test. I want to be sure the user interface has that thing labeled that way for me to click on, and I'm going to click on it and see where it takes me. So think about what you want to do. There's great stuff to deal with forms. You can click a button. Okay, and so maybe you have a submit button, and you can click on it. So this is be a button on the page, not a link or anything, but be a button that has the text submit as part of it. Again, you might prefer to actually code this with an ID on the elements so that you don't actually have to deal with that. If you're using, as you should be, the form mechanisms in Rails, when they make inputs and submit buttons, they always label them with IDs. How do you find out what those IDs are? Create your view, run your view, then view the source, view the HTML source, and you'll see ID equals this, ID equals that, and then you could use that in your Capybara calls. You can fill in forms. So you can have a fill in method call, and you could fill in, you'd find the element that has name, and oh yeah, I want to fill it in with the name Bob. So it would type Bob into the field on the form that has a label name. Oh, great. All right. There's tons of this stuff. There's things for checking checkboxes, for doing selects, for doing radio buttons. You just got to look it up in the documentation, but there's ways to basically interact with the web page fairly simply if you're using Capybara. It just takes a little bit of reading, looking at examples and things like that. Now, one of the big things with Capybara is that the HTML that gets returned to you, so this HTML page is available so that you can actually check and test what's going on with it. And so you can do tons of stuff with it. Yeah, I actually just wrote do tons of stuff with it. All right. I don't know if that was necessary to write. But anyway, so you could check, for example, does the page have some content on it? You want to verify that the page, maybe you've gone to a page and you know that a flash message of some sort should have been displayed. And so you just want to check that, sorry, invalid is displayed on the page somewhere. That's one way. You just go, oh, page. Do you have this somewhere, this string somewhere in the page visible to the user? If so, return true. If not, return false. And so you could put this, you could be like assert page has content. And if it does have it, it's passed the assert. If it hasn't, it's failed. Again, so this is just returning the Boolean, and you would use it as appropriate. All right. You can search for elements in the page. So by elements, again, HTML is filled with elements, all these tags, div, anchor tags, all sorts of stuff, paragraph tags, those are all elements. You can search for elements on the page and interact with them or inspect them. See what their content is, do other sorts of things. But the idea is you've got this whole web page, and it's not just a blind search. You can be very particular about, I want to look exactly to see, do I see something on the page in a certain way? So for example, imagine you could take the page and you can write a find. And so this is, we're going to query the page to try to find an element. And we're going to use a selector in the style of CSS. The nice thing about this, so if you learn about how to do CSS, this helps you learn how to write ways to find elements on the page. And so one of the ways is, you say, I'm going to be looking for an anchor tag. So again, these are links on the page. So an A tag. Now this A tag, though, it should have an href, which is equal to, and I'm going to insert here what the href I want to find is. I want to find the sign up path. All right. And so I ran out of space on my little teeny whiteboard. So I'm going to find an anchor tag that's got this URL as the href. All right, so it's going to search, and if it finds that element, then it's going to return it, and then I'm going to call on that element. I can say, well, click on the doggone thing then. So it's like, go look through this page and find me a link for the sign up path because I want to click on it. It'd probably be a lot easier to do this with an ID, but this is one way to be like, I know on this page I'm supposed to have a link to go be able to sign up or create an account or something. All right, from this page I want to go click on it. In other words, this would allow you to do behaviors and actions on the page where you don't care about how the link is displayed. Does it say create account? Does it say sign up for account? Who knows what it says? But you know what? All I really want to do is to go from this page to that page via clicking on the link. So let's just do that, because I'm not testing the display of the UI. I'm testing like there is a link on this page that gets me to the page I want to go to. All right. Capybara has a whole bunch of other convenient methods to make your life easier. An example with this might be something you can just, there's an assert text, and this actually, you know, I keep talking about creating accounts. It's obviously an example I like, but you could be like, this is a special assert that goes and searches the page for you and says, is there some text on it that says create account? And if so, it's passed the assertion. If not, it's failed and your test has failed. All right. And remember, this Capybara and the systems tests, these end-to-end tests are all about the user interface, the UI. If you, when writing a test, if you want to access, let's say, the session of the user, and other sort of behind-the-scene things that are not in the user face, and other, you know, lower level stuff. This is really tells you write an integration test, because they're available in the integration tests. You can access the session, you can find out what's going on with the responses and all sorts of stuff. That's where those tests are designed for. When you're working with these system tests, these end-to-ends, it's all about working at the user interface, pretending you are a user, okay? So keep that in mind. Don't try to start doing other stuff with these tests. All right, let's take a real quick, we're gonna wrap this up now. Let's show you a real quick example. So you could write this out by hand, some of this stuff, but it's really nice that Rails has an ability. So in your terminal, inside of your app directory, you can say Rails generate. You can say, I want a system test, please. And this is so you don't have to remember all of these hierarchies and how to inherit. You just get some boilerplate code to get you going. So let's say we do Rails generate system test. And then what this is going to do is create for us, this creates a file in the directory test system. So it organizes them for us. And then it makes it plural. So it goes links test.rb. Okay, so let's say we go and we open up that file now. You're going to see it with some default stuff in it. I'm going to show you, like, here's what we can end up with. And so inside of this file, at the very top, it does a require, this whole long word, not word, it's the class name. So application, it's not the class name, sorry, it's the file, but inside of it has the class application system test case. So that has to be there because we're going to make one of these classes. And then so you'll see then it goes and it says, oh, I've named it links test. So not links, links. So again, takes the link, makes links test. That's our snake case. And then the actual inside of the file, it's in a camel case, the class name. So links test, and it inherits from the application system test case All right, so this class is of type application system test case. It inherits all that functionality, which again goes up that whole hierarchy and inherits from Minitest test case. So let's write a test. So as we said, it's easy. All we have to do is precede it with test underscore, and we want to write a good, helpful name. So I'm going to say test nav as in navigation, route to back to creating an account again. All right. So the idea, create a name for your test that explains what it is you're going to test. I'm going to be testing navigating from the root to the create account. It's just and that's why this is the whole idea. I'm going to test some links, test some navigation links in the application. See if they actually exist for the user to use. Pretty simple test. It's handy. You know, you can think back to like Spell Manager in 245. We said you have to have a link that goes from here to here. Well, you can write a test to make sure that that link is really there in the application for the user to actually click on. There, you will see when you run the Rails generate system test that there is another way to define these methods. There's a shortcut that's basically uses the word test, and then you put a string, and you just type in any string that's a description of what the test is, and you can write it, you can follow that format. You're welcome to do that. It behind the scenes turns it into a def test, blah, 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 blah for you. So you can either write it explicitly and see the Ruby name, or you can use, when you generate, you'll see how to do that. A lot of people prefer that. They think it's a lot easier. So I'm going to visit the root path. I'm going to go to my home page, which my goal here was to go from the root to the create account. I'm going to be really easy in this, and I want to actually be sure that the user sees a link that says create account. And so Capybara will look to find a link that says create account. It will click on that link, and then what I can do is I can be sure that I actually got where I intended to be, that the person who wrote the view did not send me down the garden path and send me to something else other than my sign up path. This is basically checking, did I end up where I expected to be, which is on the sign up page, by clicking on a link that was create account. We end our method there, and we end our class there. You could, again, you'll have lots of these methods inside of one of these classes, and you could see, oh yeah, I'm going to write test after test to test various navigation links in the system. Easy. All right, how do you run your tests? So if you're at the command prompt, you can run all of your system's tests by doing Rails test : system, and that would run them all. I highly recommend doing -- verbose to get more output. Right now you don't have too many tests, so it's nice to see some more stuff. In the future, when you have lots of tests, you might want to turn off the verbose because it'll just fill the screen with stuff. But for now, it's nice to see what's going on. It doesn't actually put out too much. So that will run all your tests. Now, you can actually, let's say you're working on a specific set of tests and you want to just run those. It's absolutely reasonable to do that. And you can do that. What you do is you do Rails test, and then you go and you give it the file that's got the test in it you want to run. And so in this case, it's test/system/links test.rb. And again, you can specify -- you could specify in here -- verbose. But either way, this lets you run all the tests within this file, and that's a handy thing. Note that you're not doing the : system here. So Rails test with something here where the file contains Minitest tests. It'll run them all and report them to you. So you can see, actually, it's not that hard to get up to speed with starting to write some end-to-end tests. I sure hope that I see this in sprint 1 with everyone. Otherwise, you're going to be sitting there writing a whole bunch of manual test cases and forcing yourself to go through the manual test cases. It's not that bad, but it's also not that bad to write these guys, and it's kind of cool, I think. All right.